Let me continue the lecture about why we require these limits, then allowances, various types of tolerances. One of the first thing you should remember is the application. So if you look down here, you see here there's this whole thing is about limits, fits and tolerances for the ISO system. Parallelly, things like what the American standards, then where we come from, we were under, we had adopted the British standards. Similarly, you have the Japanese industrial standards, then you have the GHOST, that is Russian standards, and huge number of European, including DIN and VSM and so many other standards have come about it. And the whole thing has been incorporated into eventually what became the ISO system, because in general things are a little similar in this. So I thought I'll start with a very, very simple thing. Here you have two tube clamps which look innocuous. It looks like they're very simple and it's just fine. Now you'll end up with two different situations when you want to fabricate it and make a drawing for it. Why drawings are important suddenly it becomes because the moment you mention that this is meant for a 3/4 inch water pipe and this is meant for a 1/2 inch water pipe, once again this is meant for a 3/4 inch electrical conduit, this is meant for a 1/2 inch hydraulic piping, several other things come into picture. While externally it looks nice, the whole mention of the, we have a large array of these accessories which come with each of these items. So one of the things what you will notice is that what is considered, if you look at this picture now, you see here, this is how things are sold. Something is written here saying this represents a 20 mm this represents a 20 mm adapter. I do not know, maybe it's meant for a flush tank. Everything is indexed with reference to the internal diameter of the pipe, and from the internal diameter of the pipe you have the threads, and if it is sold as a set, often you have a nut here, then you have the equivalent, there's a flange here, there is a small gasket, and the whole thing is assembled together across a small plate, and water is not expected to leak. Whatever happens, it is supposed to stay under all conditions. These things are supposed to be interchangeable, and if not now, eventually these things have to mate with other things which are also off in the market. So you see here why I have picked this is, so you have something saying 3¼ inch to 1/2 inch and 3¼ inch to 3¼ inch, and all possible combinations are given here. This is where it is very, very critical on how do you specify the matching parts and tolerances on these things. You may be wondering, why are you stressing on all these things? At this point, let me show you, even electrical items invariably end up with drawings like this. It looks somewhat scary. What we thought was, which is just an electrical a connection, when it has to be manufactured, invariably it will end up with such documentation, and in this documentation everything is very, very, very specified. It is very, what do you call, almost a contractual understanding between the supplier and the purchaser. Hence, when you go to the shop or if you go online and ask for a simple USB extender, with all this big thing, it is a simple USB extender, but looks complicated. But when you look at this drawing, you see it just doesn't look like a simple USB extender. On one side you have the header, and one side you have the other matching portion, and then as you enlarge them, you see here a nice, fantastic amount of dimensioning has been given here. You have seen this, which I had shown you earlier, saying in one of the designation they have written saying it is 5 millimeters. 5 is shown there as a diameter symbol, and just a 5 is written there. And one of the first thing you will notice is you need not worry on what language is written. So whether you import it from Sweden or you import it from, let us say, one of the earlier socialist countries, or if you now get it from PRC, everybody can read it, nobody can worry about it. And now further about it is, across the 5 millimeter plus or minus 0.2 millimeters is mentioned there, and it is explained what that 0.2 millimeters is. You have seen this. In this case, it is translated into the equivalent inch things. So approximately if you take 25 mm to the inch, it comes to 0.2 inches. This is the beauty of having various types of drawings. One of them is there are good electrical characteristics mentioned, which we need to understand all the time. One of the thing is saying it's a 300 volt DC, and then they also have given high potential test saying at a specified milliseconds it will not fail. And down here if you see other things regarding what is the bending that it can take, 30 times per rate, then what is the bending cycles minimum, and all this, these are all guaranteed about it. This is, it's not actually a military, or it's not a military standard, but this is high grade professional standard. That is the reason why if you buy an automobile, I am sure if you run it for 500,000 kilometers, the electrical generally doesn't fail, only a few bulbs fail, other things fail. But they, now these days we have the engine management unit which continues to work, and the new devices under the, what do you call, dashboard, you also have another connector which I had covered in earlier thing. They bring the, what do you call, your connector, a pad which is fitted in that, it is connected to that, and it will give you real time all the conditions of the program which are there. And with all the new sophisticated things, these things have become all the more important. What we used to think is a relatively simple thing about just go to the market and get a connector, suddenly has improved dramatically. You see here there is a small part number, and related to the part number is length of this thing. So you have something which is this what do you call, 30 centimeters, 60, then you have 90 and so on like this. No, equivalent 1.8 meters, 1.2 meters, all these things are available, and the most important thing is they are interchangeable. You can get an alternate source in case this fails, and where the documentation is there and things are there, things generally there is very little chances of things failing. This looks very commonplace, what is called a USB type A. I am a little confused about it, but I will call it a plug. The other no is the what you call other side, the probably the matching part. So one is called a header, another is called a plug. These things, if you see carefully, huge amount of documentation and all of these things come with large amount of documentation. And what all you would like to use in your design is all already there. Why I am mentioning it is, earlier somebody had to manually draft all these things, but right now one simple way is, in case this one is a what I call a PDF document, and you can take all these small screenshots and still make a template and use it in your equipment. So when you are trying to make a layout of the printed circuit board, you can take the plan view, and when you are trying to make a panel or other thing which which shows here, we can try to take this view about it, attach all of them together and make sure that this device sits perfectly in your design. Now for our clarification, they have also given a picture so that it is easier to identify. You have seen here various other things have been given here. One of them is what is the material, what is the contact, and then 30 microns micro inch gold plating, and on the solder thing, what is the thing including tin plating. Most important is current rating and so on. All these things is where your technical drawing is very, very critical. On one side you have the manufacturing specifications, on another side you have all these things where somebody has to use this in a practical design. Typically I just gave a search. When I gave the search last time, say how many hits have managed to get. This is the usual dongle. One finds the dongle in the case of various other things, and then anything you want, everything you want is available as valid documentation for manufacturing. The one I have shown you earlier was a little related to just mechanical, and then you see here what else is here. Can you notice they have given the footprint and solder pads where it is supposed to be soldered, and this is where the convention helps. There is a dotted line here, and then you see here there is a, this is called a chain dotted line. Typically a chain dotted line represents the midpoint between two. So if you take the total weight, this is approximately at the midpoint, and they have avoided tolerancing because this is a contract document. It is for you to go and purchase it and then use it in your design. If you now look back to the earlier lecture I have given you, one place I have given you a remote control, and in the remote control I have given you keypads where you can place the keypads. In a similar way, just like you can place the keypads wherever you want, in a similar way the product concept team should fix where all these input and output connectors are fixed, and when you fix these connectors, part of the layout is already ready. This is slightly different from the development boards which we get. We get Raspberry Pi, Arduino, then we get BeagleBone, then we get so many of the other various types of small development PCBs, while sometimes the things are so neatly packed and you cannot do better. If you are thinking of a larger embedded system, typically, let's say you have a dishwasher and you would like to use all these things in that. In that cases, it is not appropriate for you to keep on populating with so many other unwanted hardware. So what those people will do is they will capture the schematic and probably they will make it into manageable subsystems. Typically easiest thing you can imagine is the power supply versus the processor, and after that invariably, because we are working with a very large system, there will be motors, there will be blowers, then there will be heaters, all of them will be connected via relays. So sometimes all this information is passed on to an output board, and output board can be intelligent, and it is common between several models. The cost of manufacture is reasonably low. So the main power dependent thing is changed. Well, supposing there is an output relay, one of the machines may not have a internal heater inside. So no point in populating it with a huge relay which costs money. So they will probably omit it, or they will not populate that particular point, because in this case the heating may be external, there may be hot water available outside, and some places you may require other things. In some places the things like separate treated water may be available. So you may need a treated water thing as a rinse for the last cycle. All these things the system is conceived at the highest level, and as much as possible they will take usable things and then try to put it together. Now I will come back to the very commonplace example I wanted to show you. You see here I have two small clamps here, and you have a look at this device which I have tried to get. Yeah, this is very interesting thing. In case you are all people who enjoy little bit of photography, intentionally I have brought this. You see here, this is a monopod which I am trying to use and convert it into a stabilizer. You see the diameter there. Obviously I need something here, and you see the diameter here. This is something here, both of them. This I have just taken it randomly from the shelf. This I have taken it once again randomly from the shelf, but miraculously, have you noticed, both of them seem to be fitting extremely well. And now when I come to this critical point, can you see here, these are all, this is a very complicated assembly made with, there are two small bearings inside this. Yes, in this I am able to move it, and there is also one more bearing in this direction. This is the vertical direction, so I will call it the z axis. So z axis this moves, x axis this moves, and intentionally I have removed the handle so that you can see the tiny small bearings. So the outside diameter is 12 mm and inside bore is only 4 millimeters. I am sorry, 5 millimeters. So this whole thing, now the magic is everything here is off the shelf, and everything here is completely interchangeable. So should I want to buy this and keep it in a large production, I have multiple sources for this. I need not go for very expensive aircraft bearings. I can probably select something which is almost commercial. Such things now are called off the shelf. So I have taken off the shelf bearings here, and intentionally I have removed all that so that you can see that there is actually a small bush and all that. The thing, once the moment I make it, now this thing is fully interchangeable, and this is a head. This head also has been made such that I can now take it into any other direction and have a genuinely universal device all assembled from just off the shelf components, which I think is a miracle of standardization, miracle of modern engineering and so on. Otherwise, nothing fits. This is actually quite a complicated thing. Of course, these days they are available at a low price. And now if you look at this yoke which has been used here, the yoke has been made considering all the off the shelf components, how much of area is this angle of operation is required, how much of movement is required. Based on all this, I have designed, and the first attempt everything has worked, which we are not able to do this a little while back. And I will say it is thanks to using of a this engineering with several types of limits and fits. Now, have a look at even my glasses. You see, this is very tiny. The screw here is very, very tiny, and in fact, it is extremely tiny, and including these have all been standardized to such an extent. And there is a beautiful spring mechanism inside, so that it bends outside, and all of these are mass produced and everything fits the other. Only the external parts are made as per any aesthetic design. Can you see it? There is a something, there is a spring inside this, and that is coming out and it is operating this. And the magic is they are all mass produced and does not cost much. This whole frame probably costs $5, and a very professional frame costs maybe the full assembly will cost you around $200 to $300. This is a very off the shelf thing, except that the prescription glasses are expensive. What makes it interesting is that all of them are, there are specific standards about what is the screw, what is the tension in this, and how these things nicely manage to fit together. Now, if you look back at that monitor, you see a large number of what are routine things are available off the shelf. If you see, internal diameter is specified as 5 millimeters, outer diameter is specified as 16 millimeters, and the width of it is 5 millimeters. So, these things, and in this case it looks like it also has a nice race and a device which holds all the balls in place, and the main magic is they are all interchangeable. If not this, I have other suppliers who can supply these things. Price varies a little, professional quality and branded cost a little more, and commercial things do not cost so much. Anything you can think of is probably here. Why I have picked out of it is, this is a gimbal controller driver, and you see in all the directions they have beautiful connectors talk with another subsystem, and you have anything you want already there. So, you see here there is a small I right now will avoid concentrating on the electronics. What I wanted to tell you is, you see here in the 4 corners there are 4 mounting holes, and there are pins for connecting other things. Then this is probably I won't know whether it is a power supply or whatever it is. Everything is standardized, everything is easily available, and you see here other things have been written here saying there is something which controls the roll pitch, front and rear. Everything designation is there, and the magic is, best part of it is they are all fully interchangeable. We have been able to achieve a state like this mostly because of the sticking to limits, fits and tolerances, and right now, depending on whichever area you are working on and depending on the industry which you are associated with, there are huge engineering manuals and data books which are available, or handbooks which specify everything that you need to do. In the building industry, you would have noticed that we have bricks. We have the old one type of bricks, and then in our case, we have the new metric bricks, which are all typically are 20 mm by 20 mm by 30 mm, or 20 by 20, 30 into 40 mm, and so on. All our bricks are standardized, and even the aggregate sand and even other things which are used are also specified, saying this is the grit, this should be the maximum, this should be the minimum, and so on. And documentation and industrial practices have been done. This, though it looks like a mechanical job, if you are a product designer, it is your obligation to read everything and get it back to this. Let me show you this. This is a small box for holding my hearing aid instruments. It looks nice. It has a soft thing and all that, and I can remove my hearing aid and safely put it. Then there is a place here for storage of the batteries and all. And this is where you see here, looks fine, is it not? Everything looks fine, except that the bigger miracle for me is this is a rubber insert, and this one is just a plastic box outside. See how well this elastomer sits well inside, and in our case, this is meant for a very expensive hearing instrument. Hence, lot of money has been spent on this, saying how you can open it and you can store things inside, close, and it is generic. The core can be easily changed, and we can come with several other products. And yes, design is expensive, and the whole unit turns to be expensive because a limited number are made. Not that many hearing aids are made by one manufacturer, and as such, because of the fitting and because of the medical and one device for each person, things have to be very, very specific, otherwise it won't go into my ear. However, when you take things like these watches, it looks like technology is fairly standardized. It is a question of quality control, brand building, and the type of service which they give you. And these are all almost keepsake type of things. But the background of all of it is documentation, universal fits and tolerances, and manufacturing. And even though you have an electronic product, it is expected that all these things are taken care of. I will stop here and continue in the next thing. While I have taken some very general items here, I will try to take next time, I will try to take one printed circuit board and try to show you how the interface between an enclosure, the printed circuit board, and now we come to the other thing, saying from all the sides you have the connectors, and after closing it should work with full environmental protection. So often we have these IP classes. So it is expected that if briefly your mobile phone, you walk with your mobile phone in the rain, it is unlikely that it will be affected, and you can even take it to the beach, but you can't dunk it in water. So these things have all been over the years, they have been evolved to make sure that 100% interchangeability is there, and the core of that is documentation. Just like it is as big a problem of making documentation for your electronic design, in the case of mechanical design, that is also clear. A small amount of help is on the way, because if you take, even if I take my 2 clamps, generically they are a little same, and once if I make the proper inner diameter, proper way of doing, and then at what level I would like to clamp it and all, scaling it to any other size is easy. So, once somebody has to work on all these things, once they have worked on this, these two can share a common 3D solid. This 3D solid is absolutely, there is no problem, and related to this 3D solid, even analysis, in this case if you see very carefully, there is a small embossing here. This embossing gives that necessary stiffness, and also it makes things to be stable, and all this is taken care of automatically. And with the newer packages, what I told you, bidirectional associativity is there. See, instead of having 20 mm tube, if I just type the next closest say 25.4 mm, all the proportions, everything are maintained, everything is adjusted perfectly, and you can always fabricate a piece. And one of the early lectures I have shown you sheet metal using CNC. So, CNC sheet metal also is available, but the focus of it is something, a concept you need to have, put it into documentation, and documentation is needed when you want to talk with each other, but your CAD files are available, and one proper proven CAD file from your design can easily be transferred for mass production. So, thank you. We will meet again.